Hello friends, I am Chandan. This is a good question of from second law of thermodynamics. Let's try to understand this question. Okay, so here, if a what is given in this question? If a reversible heat engine operating between thermal reservoir at 800 degrees Celsius and 30 degrees Celsius drives a reversible refrigerator which operates between minus 15 degrees Celsius and 30 degrees Celsius. The heat supplied to the engine is 1900 kilojoule and there is a neat work output of 290 kilojoule. So determine the cooling effect. Second, total heat transfer to 30 degrees Celsius thermal reservoir. You have to find out these two question to answer. Okay. So what is given in the question? The engine which operates between 800 degrees Celsius and 30 degrees Celsius, and the refrigerator which operates between minus 15 degrees Celsius and 30 degrees Celsius. Okay. The heat supplied to the engine is 1900 kilojoule and there is a neat work output, okay, 290. So these data are given in this question. You have to find out the cooling effect and the total heat transfer to 30 degrees Celsius thermal reservoir. Okay, so just what is given in the question. So in the question given that there is a heat engine. The heat engine operates in between. Here the temperature 800 degrees Celsius. So here temperature is in degree Celsius. Temperature is in degree Celsius. Okay, 800 degrees Celsius means 800 plus 273 Kelvin, that is equal to 1073 Kelvin. So for each case, if there is a degree Celsius, you have to convert it to Kelvin. Okay, so 800 degrees Celsius means 1073 Kelvin. 30 degrees Celsius means 303 Kelvin. Minus 15 degrees Celsius means there is a 258 Kelvin, and 30 degrees Celsius means there is 303 Kelvin. Okay. Now the heat engine operates between these two temperatures, that is 1073 Kelvin, 1073 Kelvin and 303 Kelvin. 30 degrees Celsius means 303 Kelvin. And heat engine produces work, that is W1. Basically heat engine absorb Q1 amount of heat from the source, that is one source is at 1073 Kelvin, and reject the heat to the sinks which is at 303 Kelvin, and it reject the heat Q2 amount of heat. Okay. Now there is another two source and sink. This is the source here, that is 303 Kelvin, and this is the sink, that is 258 Kelvin. Okay, 258 Kelvin, and in between this reservoir there is a refrigerator is there, and here refrigerator we have to supply to run this refrigerator, that is W2 amount of heat, W2 amount of work has to be supplied to the refrigerator, and the refrigerator absorbs the heat from the storage space, that is Q3 amount of heat is absorbed from the storage space, and it rejects Q4 amount of heat to the source of 303 Kelvin, that means 30 degrees Celsius. So you have to find out what is given, the cooling effect. You have to find out the cooling effect. So you have to find out what is the Q3. You have to find out what is the value of Q3 and the total heat transfer to 30 degrees Celsius thermal reservoir. So you have to find out the total heat transfer to 30 degrees Celsius thermal reservoir. So here is a 30 degrees Celsius temperature, that is 303 Kelvin. So here Q2 amount is heat is supplied to the 30 degrees Celsius temperature, and here there is a same reservoir, that is 303 Kelvin, and here that is Q4 amount of heat is transferred to the 303 Kelvin reservoir. So you have to find out what is the value of Q2 plus Q3. So these two value you have to find out. Okay. So another thing is that uh, the heat supplied to the engine is 1900 kilojoule. So the value, the heat supply here, the Q1 amount of heat is supplied to the engine. So the here data is given, that is Q1, that is equal to 1900 kilojoule. Okay. Now if you want to calculate the reversible engine efficiency, that is equal to, you know, that output by input. So W1 by Q1. What is the input? That is Q1. That is Q1. So what is input? That is Q1. So Q1 is the input. Q1 is the input and W is the output. So W by Q1, that is equal to, you know, that 1 minus TL upon TH. We know that 1 minus TL upon TH. What is the value of TL? 1 minus 303 by 1073. Okay, 1073. Now, and Q1 is given. So from here you can find this W1 value. W1, that is equal to 1363.47 kilojoule. Okay. So from here, if you want to calculate the efficiency, we know the formula, this formula, that is efficiency, that is output by input. So what is output? That is 1363.47 kilojoule divided what is by input, that is 1900 kilojoule. So from here you can get this data, that is efficiency, that is 0.717. Basically this is 71.7%. Okay. Now here the Q1, that is basically 1900 kilojoule, 1900 kilojoule, and W1 we get the W1 value, that is 16.63.47. So 1363.47, 1363.47 kilojoule. So what is the value of Q2? We know that here this is our system. Here Q1 is entering and W1 is outgoing from this system and Q2 is outgoing from the system. So from the first law of thermodynamics you can say that Q1, that is equal to Q2 plus W1. So from here you can find this Q2, that is equal to Q1 minus W1. So what is Q1? That is 1900 minus what is W1, that is 1363.47 kilojoule. So from here you can get Q2, that is equal to 536.5 kilojoule. Okay. Okay. Now another data which is given is that here another is given, that is there is a neat work output, that is 290 kilojoule. So here there is a output, that is W1, and there is a input, that is W2. So what is given in the question? W1 minus W2, that is equal to 290 kilojoule. Okay. So here W1, that is equal to 1363.47 minus W2, that is equal to 290 kilojoule. From here you can get this value, that is W2, that is equal to 1073.63 kilojoule. Okay. Okay. Now focus on the refrigerator. So we found this value, that is Q2, so W2 is basically 1073.46 kilojoule. Okay. Now focus on that. If you want to calculate the COP of the refrigerator, that is basically equal to Q3 by W2. So here for refrigerator, this is the cooling effect Q3 by work input, energy input, that is W2. So Q3 by W2. So that is equal to, so consider this is T3 temperature. This is T3 temperature. So consider here this is T3 temperature and this is T4 temperature. Okay, so T4 temperature, that is 303 Kelvin, and T3 temperature 258 Kelvin. So here T3 divided by T4 minus 33. We know that this formula. Okay, so here WT is given, T3 is also given, and T4 and T3 is also given. So from here you can get this Q3 value, that is equal to 66154.53 kilojoule. So this is our first answer. So what is the cooling effect? This is our cooling effect. Okay, this is our cooling effect, that is 6154.53 kilojoule. Okay, now if you want to calculate the COP, so COP we know that the formula, that is Q3 by W2. So if you put this value, this is will be 5.73. Okay, now so from first law of thermodynamics, here Q1, W1 is going, W2 is going to the refrigerator, and Q3 is going to the refrigerator, that is equal to Q4. So Q4, that is equal to Q3 plus W2. Okay, so Q4, that is equal to W2 plus Q3. Okay, so what is the value of W2? That is equal to 1073.46, and what is the value of Q3? That is equal to 6154.53 kilojoule. So from here you can get, that is 7223.27.9 kilojoule. Okay, now in question you have to find out the total heat which is transferred to the 303 Kelvin. So here the heat is transferred, here there is a Q2 amount of heat is transferred to the 303 Kelvin, and here also Q4 amount of heat is transferred. So what is the total amount of heat? That is equal to Q2 plus Q4. Okay, so here if you want to calculate this Q2 plus Q4, that is equal to, so what is the value of Q2? That is 536.5 plus what is the value of Q4? That is equal to 7227.9. So here the answer will be 7764.6 kilojoule. So this is our answer. Okay, so these two are answer. Okay, the cooling effect, this is one answer. The second answer is the total heat which is transferred to the 303 Kelvin temperature. Okay, now let's try to understand another question. This is also very important question. Okay, so here what is given in this question? A household refrigerator is maintained at a temperature of 2 degrees Celsius. Every time the door is opened, warm material is placed inside, introducing an average of 420 kilojoule, but making only a small change in the temperature of the refrigerator. The door is open 20 times a day, and the refrigerator operates at 15% of the ideal COP. Okay, the refrigerator operates at 15% of the ideal COP. The cost of electricity is rupees 2.50 per kilowatt hour. The monthly bill for this refrigerator is rupees what? You have to calculate the monthly bill to running this refrigerator monthly. Okay, and another is given that the atmosphere is at 30 degrees Celsius temperature. So atmospheric temperature is given, that is 30 degrees Celsius temperature. Okay, now focus on this question. So there is a surrounding, and that is basically 30 degrees Celsius temperature, that is 2303 Kelvin. And there is storage space, and this is basically 2 degrees Celsius temperature, that is 275 Kelvin. Okay, and there is a door, and this is the door here, and the door is open 20 times per day. Here in question, the door is open 20 times a day, मतलब एक दिन में 20 times. Okay, now here for each time there is a 420 kilojoule of heat which is into the storage space. The heat is transferred to the storage space. So what is the total amount of heat per day? That is 420 into 20 kilojoule per day, because every day the door is opened 20 times. So that is why 420 into 20 is multiplied. Okay, so here in question the given is that introducing a average of 420 kilojoules. So warm material is placed inside, so that is why there is an introducing an average of 420 kilojoule. Okay, the 420 kilojoule of heat which is transferred to the storage space. Okay, and this is 20 times, so that is why 20 is multiplied to 420. Okay, and so in between there is a refrigerator, and refrigerator basically absorb the heat from the storage space to maintain, that is 2 degrees Celsius temperature. That means the amount of Q2 will be 420 into 20 kilojoule. Okay, and there is a work transfer, that is W amount of work transfer, and Q1 amount of heat which is rejected to the surrounding. So you have to find out the monthly bill for this refrigerator, to run this refrigerator. You have to find out in this question. Now what is given in this question? Here focus on this. The refrigerator operates at 15% of the ideal COP. Okay, so you can say that the actual COP that is equal to 15% to the maximum or best COP. Okay, so here if you want to calculate the actual COP, that is equal to 15% means 0.15 into what is the best COP, what is the so this is basically COP. Okay, sorry for that, this is COP best. So COP that is equal to TL upon TH minus TL. We know the formula COP we know the formula, that is COP of refrigerator that is equal to TL upon TH minus TL. Okay, so here that is TL, that is 275 and TH minus TL, that is 28. From here you can get the actual COP. Sorry, this will be the COP. Okay, this will be the COP. Remember this is the COP. The actual COP that is equal to 1.47. Okay, the actual COP that is 1.47. So actual COP, so here the actual COP that is equal to output cooling effect by energy input. We know that cooling effect by energy input. What is the cooling effect? That is Q2 is the cooling effect by energy input W. So from here, so Q2 by W. Okay, so what is the COP? That is equal to 1.47, and what is the cooling effect? That is 420 into 20 by W electrical input. Okay, so from here you can get this data, that is W that is equal to 5714.29 kilojoule per day. Okay, per day. Now if you want to get this value per month, you have to multiply it by 30. So this will be, so 30 into 5714.29 kilojoule. We know that 1 kilojoule, this is very important, 1 kilowatt hour, that is equal to 3600 kilojoule. So from here 1 kilojoule, so from here 1 kilojoule, that is equal to 1 by 3600 kilowatt kilowatt hour. Okay, so if you want to convert this into kilowatt hour, you have to divide this 30 into 5714.29 divided by 3600. From here your unit will be calculated, that is 47.61 kilowatt hour. This is basically the unit for month, in a month. Okay, now in question, what is given in this question? The per kilowatt electricity is, per kilowatt hour electricity is rupees 2.50. Okay, the price per unit electricity is 2.50 rupees, 2.50 rupees. So if you want to calculate the bill for the month, the total unit is 47.61 and per unit rupees is 2.5. So from here you can get this will be the answer, that is 118.78 rupees. So this will be our answer. So the total unit will be total rupees will be 118.78 rupees. Okay, thank you.